Yeah, so if you see something like 2 with a little 3 here, it's the power of. We haven't done those yet, but something like that, or little x with a little squared there. That's 2x times x, okay? Then we have, of course, division and multiply, or multiplication, and then add and subtract. Now, did you know that this is one spelling of it? And I know you know PEMDAS and maybe BODMAS you've heard of, but you could also spell this word BEMDSA. Why can I spell it like this? Yeah, a few of you know the answer, because division and multiplication have the same power in this. They, whichever comes first, we do first. And adding, subtraction are the same. Whichever comes first, we do first. First, we do first. Does that make sense? No. Maybe it does. So if multiplication becomes before division, what do we mean comes before division?
Like in an equation, there might be more than one symbol, and if the simple division becomes before the symbol.
Yeah, so what way do we read an equation?
You have to
Left to right. Same as you read a book, you read an equation going this way, don't you? So this is first, and this bit is last. So if I have a division here and a multiplication here, I would do the division first, because it comes first in the equation. So this order is nice because it spells out a name, doesn't it, gents? And that we can remember. BEDMAS sounds a lot better than BEMSA, or whatever that is. Okay, and that's the only reason. That's the only reason. Now, does it make sense that we have this particular order? Why do we need it? Why can't we just do whatever we want? You will not get the same answer. I'll give you an example. If I have $100 and I owe 2 people $10, how much money do I really have? Okay, if I write that down though, $100 and I minus 2 times 10. Yes? That's the same thing as kind of what I just said. If I didn't have order of operations, I could do 100 minus 2, 98, times 10, and all of a sudden I have $980 from the same equation. So you can see why we have some sort of order to make sense of maths. This is just 2 groups of 10. The value of this can never be more than 20. Yeah. What about what? Rucksack. Rucksack. What does that mean? Is that for reading? I've never heard of that, so I have no idea what that is. But maybe you can teach me about it later. Okay, so this is one example of why we need BODMAS or PEMDAS or BEDMAS. It gives order to make equations correct, I suppose, so everybody uses the correct order, and we are all on the same page and we get the same answers. There's definitely some viral versions of BEDMAS where you can get 2 different answers even if you do follow the rules, but we'll come to those tomorrow. So I'm going to do a few examples here now for you guys. The Americans like to say parentheses instead of brackets, so that's why I put this one up with a P. The kind of British say brackets, up to you which one you use. I'm okay with both. Let's look at a few examples here. The first one, 8 plus 4 times 2. What is my answer here? Makes a shaky camera. Okay, so which do I do first?
multiplication.
Okay, I look at my order. If there's any brackets, there's none. There's no exponents. There's division and multiplication. I do this first. So I have 4 times 2 first, and then I do my addition to give 16. So that just tells me to do this bit first. Second example here, 6 plus 3 in brackets multiplied by 5. 45. Yeah, okay. brackets, there are brackets, so now I do this first. I don't multiply the 3 by the 5. I do my brackets first. I get 9, and now I multiply by 5, and I get 45. Okay? The next one up here starts maybe get a little bit trickier. 18, 2 plus 1 multiplied by 3. What's the first thing I do here? I must do my 2 plus 1 first. So I can rewrite this as 18, and now this is 3 by 3. So which do I do first? Multiplication, yeah? No, now we're in a case where we've division and multiplication. So which one do we do first? We do whichever comes first. Because remember, we can spell BEDMAS the other way. Isn't that right, Alexander? Yeah. This one comes first. So I'll do it first. 6 multiplied by 3 is 18. Okay. So shockingly, dividing by 3 and then multiplying by 3 gives the same answer as what we started with, because they're opposite operations. If I add 3 to something and then subtract 3, I get the same answer in the end. Okay, let's do maybe just the last one here, question 5 on the board, and then you guys get to do some. So there's loads of brackets here. Maybe you can think about what we have to do if there's double brackets. Yeah, and what's the square about?
Always like the brackets outside of it.
There's brackets outside of brackets. So which one do I do first? Yeah, so does the square brackets mean something than the curvy brackets? No, they're just two different sets. So it's just different, because if I use curved brackets for both, you would be unsure where one bracket ended and the other one starts. Maybe it's these two that go together and these two that go together. No, but these two I know go together because it's the same type of bracket. So do the innermost bracket first. It's like a Russian doll set of exponents here, or not exponents, operations. This first, then this. So 6 times the 2 is 12. Well, we're going to see. Plus 4, and then I'm going to do this as well. 3 plus 2 is 5. What do I do next? 4 times 5 next, yes. So any multiplication done before you do any addition here. So that's 20, and I get my answer, 32. So it's good for a long one like this to do